This is chapter 3, beginning with polynomials and rational expressions, but 3.1 specifically has to do with quadratic functions. So a quadratic function you should be familiar with has degree 2. This is the generic polynomial form ax squared plus bx plus c, so that makes up a quadratic. And notice what we're going to do is we're going to put it in standard form, and this right here is standard form for a quadratic. And we're going to get that by taking this to this. We're going to get from that spot to standard form by a process called completing the square. And I'll show you how to do that on the next example. But notice the vertex is hk. So for instance, if I had something like x minus 4 squared plus or minus 1. Well, the vertex again would be 4, negative 1. So notice the formula says minus, so that actually makes, so an easy way to remember it, if it looks negative, it's actually positive for the h part of it, and then it's exactly what you see there. So 4, negative 1 is the vertex for standard form for that illustration. And again, something I just want to point out to you, if a is greater than 0, in other words, if a is positive, then the parabola opens up. All right, and again, you've got the vertex hk, and the parabola is opening up. If a is less than 0, so in other words, if a is negative, the parabola is going to be going down, and again, you still have the vertex hk. And then something else, just want to remind you about the axis of symmetry. So the axis of symmetry is at h, okay, and then same thing here. Axis of symmetry at h, and then to find the k, you would simply just plug that axis of symmetry in to find out where the k is located. So let's look at an example here, standard form of a quadratic. So notice we have a polynomial form, and what we're going to do is put it in standard form, and we're going to do that through completing the square. So normally when we do completing the square, one of the first rules is you have a has to be 1. And so notice you have a number that's not a 1 in front of it. So we're going to factor it out. But what we're going to do is, for a short time period, we're going to kind of ignore plus 13, and we're going to factor out a 2. We're going to look at just these two, and we're going to factor out a 2 because we want this guy to be a 1 in front of it. And notice what we're going to do is we're going to end up, let me write this a little bit lower, just so I have enough room to write here. And to do completing the square, and I'm just going to write the 13 over there, we're going to ignore it just for right now. Notice to do completing the square, we would find that little magical number, b divided by 2, and we're going to square it. And so this would be negative 6 over 2, negative 3, and that's going to be 9. And normally what we would do is we would add 9, to one side, we'd add 9 to the other, but I want to remind you about the 2. So this is actually 2 times 9, so it's actually 18 what we're adding to both sides. So this is actually 18 we add to this side, and we would normally write plus 18 over here on the other side. But instead of writing plus 18 on this side, I'm going to actually minus 18 over here. So again, it's the same thing. So again, if instead of adding 18 on the left side of the equation, I'm going to just minus 18. So again, I want to emphasize this. That's 18, that's minus 18. So it's the same exact equation as we had before. So if we kept working completing the square, so notice this factors completely to x minus 3 in it. And then this right here goes to minus 5. And so notice I have it in standard form. That's letter A, standard form. And from that, you can see letter B, you can see the vertex, H, K, 3, negative 5. So if I go to 3, negative 5, that is my vertex. And you can also see the axis of symmetry right through there. That's the middle of the parabola. You also notice that A is positive, which means I know the parabola is opening up. So just keep that in mind, it's opening up. So we found the vertex. Now let's look at the x and the y intercept. So the x-intercept and the y-intercept, if you think of the xy chart, remember if you plug 0 in for x, it gets you the y-intercept. So plug 0 in, and we're going to get 13. So come up here at 11, 12, 13, about right here. And then remember, one of the cool principles of the parabola is symmetrical. So we're going to reflect it 3 spaces over. And so it would be that point. And then if we find the y-intercept, so literally we're going to replace the original problem. If we take the original problem, we switch to purple. We're going to take 2x squared minus 12x plus 13. And we're going to set that equal to 0 because we're setting the y equal to 0. And then you're going to solve that probably by using the quadratic. And you're going to end up getting 2 possible answers once you solve the quadratic equation. And those are 1.42 and 4.58. So 4.58, 1.42. So about right there and about right here. So if I connect the parabola here, the parabola looks like that. So I sketched the graph of it. I found the x and the y intercepts. I found the vertex. Now let's talk about the domain and the range. Well, the domain is any number. You can plug any number in that whatsoever, so that's all real numbers. The range, if you look at the range, the lowest that it goes on the y is right here at -5, and then it just keeps going up. So -5 all the way to infinity. That would be the range. Now, the maximum, minimum, we kind of already talked about it. So you got the minimum and the maximum. If the parabola is opening up, if A is greater, if it's positive, if A is positive, it opens up. So that's the minimum. And of course, you got the maximum as well if A happens to be negative. So we talked about the vertex, but again, if it's a minimum value, then we know the HK, the actual value of it is the K. So think of a soccer ball or something being kicked in the air, and the highest that it goes, let's say it goes 312 or something like that. So 3 seconds later, it's at 12 feet tall, and so the height, the maximum value would be 12 feet. All right, so that's what we're talking about. So the maximum value of that. The same thing if it goes down. So again, the K is the minimum value of it, or if it's going down, K is the maximum value of it. All right, so let's look at this quadratic and basically do the same thing. I do want to point out letter C. It does say minimum. I don't have to give that to you. You should know that the A is positive. You know that if it's positive, the parabola is opening up. And if it's opening up, it has a minimum value. So I shouldn't have to say minimum, but it does have the minimum. And remember, it has an HK for the vertex, and all we have to do is find the K to do that. So again, what we're going to do is treat this as completing the square. So we're going to take a look at the first 2 terms, 5. We're going to factor a 5 out. Leave a space. And we're going to kind of put that 49 over to the side just for a minute. And we're going to use, find that magical number. So b divided by 2 squared. That's -6 divided by 2. -3, that's 9. So if we add 9, which again, 9 times 5 is 45. So we would normally add 45 to the other side, or in this case, put -45. We've got to do that. So to make it still equal. So we still have this perfect square, and then we have +4. Now from that right there, we did it expressed as in standard form. And then letter B, if we talk about sketching it, we can see the vertex is 3, 4. And so if we sketched 3, 4, just doing a quick sketch, 3, 4 is right there. We know the parabola opens up. If we did an XY chart, plugged in 0 to find the y-intercept, it would be 49. So it would be way up at 49. So we probably want to go back and count by something different than that. But you got the idea. So even if we counted by 2s, this would be 3, 4. And then we go all the way up to 49, way up here to 49. That would be the y-intercept. And then remember, this is your axis of symmetry. We're going to reflect it to your parabola like this. So we just did a quick sketch to be able to do that. So that's what we did. We sketched it, find the minimum value of it. Again, we found the minimum value because once we found the vertex, we know the minimum value is 4. So that's how low it goes is the minimum value, which helps you find the range, by the way. So the range is 4, and it keeps going all the way to infinity. So the range is kind of helpful in that scenario to be able to do that. And then let's do a word problem just to make sure we understand how to do this. Most cars get their best gas mileage when traveling at a relatively modest speed. The gas mileage M for a certain new car is modeled by this function. So where S is the speed and M is measured in miles per gallon, what's the car's best gas mileage and what speed is it attained? So one of the things that if you remember the parabola, one of the things is the axis of symmetry. And the axis of symmetry, remember this is HK, and to find the axis of symmetry, we're going to be doing negative b over 2a. And so if we did negative b over 2a, you're going to get negative 3 over 2 times negative 128. So once you simplify that, you're going to get 42. Now remember, the axis of symmetry is at 42. So if I had to graph something like this, we go all the way to 42. And 42 would be the axis of symmetry. And then once I look up to find the vertex, all I had to do is plug 42, because x equals, so like think of an XY chart, so x equals 42. So if I plug 42 in, then I can find the vertex. So all I need to do is plug 42 into those s's. So negative 128 times 42 squared plus 3 times 42 minus 31. And this is actually going to end up, after you do the math, that's actually going to equal 32. And so you could see the vertex is 42, 32. So the car's best gas mileage is 32 miles per gallon when it's traveling 42 miles per hour. So again, notice that we're talking about this is the speed that it's doing. So if you had to graph, you got the speed over here, this is the speed, and this right here is talking about the gas mileage. So that's really what it's referring to be able to do that. So we answered that question. And just as a reminder, we just kind of went over it, but x equals negative b over 2a is the axis of symmetry for a quadratic. And so the minimum value, we already talked about hk. K is the minimum value when a is greater than 0, or when a is less than 0, it's the maximum value. But that's the way we got k was once we plugged this in, this is your x value. So once we plug this in, so it could be literally written as negative b over 2a. And this would be literally f of negative b over 2a. All right, so that's another way to look at it. That's really what the vertex is in that notation. And then I can ask you some more questions. Same thing, find the maximum or minimum values of each quadratic function. And you just have to find the axis of symmetry first, plug it in to find the vertex. And you can easily do it by doing the last example or using that notation as well.